Today I thought I'd look a bit at AMD source code on Mesa. People who made this seem to be quite good. The source AMD compiler. Here you have ACO. You can see there's quite a lot of files. SSA. Oh, okay. So I guess a lot of it is IR, instruction selection, interface, assembler. So here they kind of just like oh, they're using C++ here. I thought it was C for a second. I was a bit confused. Yeah, so that's they have methods, and they're kind of overloading on the reg function. And here they it's kind of checking. Look, if it's more than GFX 11 and registers M0, then you will return whatever this value is. Okay, so that's kind of like one of the things that they have. M0. I guess this is probably the configuration. Generally, like the first few functions will probably tell you quite a bit about it, but it's format AXP. Is that export or what? Global flat scratch. So I guess this is just kind of the assembler front end or something, maybe? Where it's kind of just, yeah, I guess it's kind of just trying to encode things. Probably from, your ASCII text format into binary. And yeah, they have a lot of shifts and, oh no, that's just a ternary operator. I thought that was a bitwise operator for a sec. Yeah. Is DPP 16? I don't know what that's referring to. SDWA DPP 8. Okay. So I guess this is probably some of the stuff that might be available. Make more sense if you kind of read the AMD's kind of ISA, GPU ISA. I think I actually tried to. Oh, no, I don't. Yeah, but I think their ISA is generally, it's kind of like it's RISC-like, I guess. So it shouldn't even be that complex in theory. So here's like their kind of driver to emit the stuff. Yeah, I think I'll also a Pi file. So I guess it's a script to kind of build stuff on. Okay, that's something I haven't seen before. So they're kind of writing their C inside a Python script. Well, I think that's actually CPP. Yeah, inside a Python script. And for they have this really special kind of operators. I'm not entirely sure. Maybe is that like a macro or something? Like a Marco template. ACO builder. Oh, my neck and back is kind of sore. Probably have to rest for 3 days. ACO interface. Might look at the few books I kind of bought. I thought they were pretty cool. Spill, validate. Let's look at the build. What are they kind of opcodes, builder, interface? Oh, okay. So here they're kind of just Um, opcodes, they kind of had their own one. Okay, so maybe that's what we look at then. Their own kind of. I don't know how to express it. I think I'll basically call it a an option, a config option or something like that. Opcodes. This could be pretty good. I guess they're kind of using Python in their generating CPP. Again, they're probably going to be where they get this from. Opcodes.keys. Oh, here. Oh man, from ACO opcodes. Here. So this is actually the driver for it. This is actually quite smart, I think. This is actually quite a good idea. Especially if you're using something like CPP. And a lot of your stuff is just data. So they actually have a lot of the instructions already, kind of here, and they probably know quite a bit about. They probably studied AMD GPU quite a bit, at least on the Linux side. RAD-V, I'm pretty sure is just is that Vulkan, Radeon Vulkan, or SPIR-V? I don't know. Yeah, probably. RAD-V. You could also use something else in Mesa. For Vulkan. So you don't need to necessarily do that. I'm not sure. I think they do publish their ISA. Otherwise, I don't know how they're going to unless they reverse engineered it. But I'm pretty sure they AMD GPU probably. There's got to be This is the RDNA 3 version. Jeez. Okay, so they do have quite a bit of stuff, I guess. The wave stuff, the storage states. Oh, so they have their registers and the shaded instruction sets as well. Instruction field. Vector source. Yeah. So, what's this table? Instruction field. Inline constant, literal constant. Oh, okay. 256 GPR work group. Man. I mean, it's quite a lot of stuff, I guess. So I guess this should probably tell you everything you need to know. And I think AMD GPU probably did have their own kind of open source compiler for OpenGL. Maybe they contributed to Mesa, or somebody reverse engineered the first one. But yeah, I mean, even NVIDIA kind of did open source some of their drivers, I think. They also put some of the stuff in the firmware, if I recall. So, it's NVIDIA doing NVIDIA things. SSA elimination. Alright. Well, I guess here they're kind of is empty, insert parallel copies. So I guess this is kind of like an LLVM thing where they're doing optimizations, branching sequences. So here is probably an outline of. Okay, so they're looking for exact copy calls to that, I guess, and then maybe they'll try to reassign exact value. Eliminate exact copy. few instructions in the block. So they talk about SALU, scalar and vector ALUs. VOPC? What's that? Comparison instructions, I guess. Vector comparison. So here, you know, they're declaring their state. They're getting their masks and instructions and turn. So if it's fine, I guess it's still early return. Otherwise, they'll do some checking. Oh, okay. Exec. Oh. I think that's just to save. This isn't even like the driver code. This is mostly just to save the old execution. The copy can be removed. Oh my god, VOPC. So I guess this is probably some of the optimizations. What is that? Okay, that's again like checking whether or not there's something there. Implicitly read VCC. This way of optimizing probably is okay. Jesus Christ, man. Okay, so I guess this is like the main driver code. Present. Okay, so they're moving, they're resetting, they're copying. Select. So I'm guessing they're kind of replacing the original stuff with maybe stuff like that. I don't know. What a mess. And you know, again, in a language like this, it's the fact that you kind of have to like manually do this stuff like that. It's just, I mean, there's probably a reason why this field is so like high in demand and stuff like that. Because there's just so much bullshit, kind of old code that we have to consider. We have to kind of build on top of. And again, it just looks so abstract, right? You're starting at index +1, and then you're you know, looping until you get to at most copy index, and the fact that, you know, even something like this, like ++ IDX or IDX++, it's just some, in my opinion, it just introduces extra kind of complexity and stuff like that. You know, yeah. IDX equals IDX +1, you know, just do that. Operand, op, instruction, operands. So here, yeah, look, I mean, if they're checking intersection between def or op or def, copy def and def. They wanted to kind of basically just early return, I guess. So, because they can't optimize it. Otherwise, they can kind of check for each of the instructions in the block if there is like a okay, so if it reads VCC like that status register, I think that's a vector or what, something like that, or voltage in. Nah. VLU. Oh, so if it deals with the vector ALU and the size is more than or equal to 3 and instruction is VOP3. Oh, okay. So VOP3 is probably the Did I? Oh, I think I closed it. Oh man, I'm like actually kind of retarded sometimes. Whatever. But AMD. Okay. What? Modifier. Oh. So is it a type of modifier or what? Oh, so it's a format. Okay. So if it's in a VOP3 format, turn. Here, that's actually the kind of code that they want to, like, okay, look, set the V compare, vector compare X. Compare X? Like XOR or what? I'll begin. Yeah, maybe they mean like XOR the both of them, I guess. Or modifiers. Reassign instruction to write the exec directly. Man, that's kind of okay. Can remove copy. So okay. So if you can if you detect the branch, and again like you know I guess it's fine. Parallel copy. Back. It's back. It's like the loss is the branch, I guess. Jeez. Remove the copy. Create instruction, pseudo instruction, parallel copy, pseudo 1 1. Okay, so definitions. Right def, yeah. Operand. Create an operand object. And set it to lane mask. Again, I think these are like vector stuff. Reset. Okay. So that's kind of like reset, I guess. Remove. So here's the actual kind of like removing a copy. Exact copy. So execute copy is the kind of the thing that they're interested in here. Alright, that's kind of fair. So they have a lot of just stuff on this, I guess. I mean that probably makes sense. If it's empty. Phi info. I don't know what phi refers to. I don't know what that is. Merge. To do division. So if they do that, I guess they could always kind of roll out an update. Is that copy and exact branch sequences? Okay. Alright. Is VOPC. Oh, okay. So if you get something like that, where you're trying to exec val, then you have an exec copy, depend on exec, and then lastly you have like your branch. So you detect something like this, you can actually just remove the copy New copy. One exec copy also saves the old exec master. Insert a new copy before exec val. Yeah. What's S? Just always on register. Very slightly beneficial. No, so again, kind of re-inciting to use that to earlier exec copy. Yeah, a new copy instruction. Well, so that's pretty interesting. I mean, and you can see, I guess a lot of this stuff is kind of to do with memory management. I guess memory and copying stuff, branching, etc. And the idea I had was to actually kind of limit that, or to make it like very simplify it and make it lazy, so that it's kind of, less of an issue, less of a kind of thing that you kind of have to optimize so hard like this. What that does mean is that you might not have as much flexibility in terms of like doing exactly what you want. You will have to kind of simulate that on a higher level, I guess. So I don't know though. I'm kind of tempted to still go into that area. So I don't. I'm just gonna keep looking around the schedule. Oh, could you actually program that? Maybe this is a software scheduler. Yeah, because I'm pretty sure the hardware scheduler is it's not like, and it's kind of optimized for throughput anyway, rather than latency. Okay. So that there's cursors, the scheduling context is downward movement. Huh? Clause? Okay, I don't know what they're referring to here. Hazard query, memory event, hazard result. Alright. So there's things like hazard, there's things like cursor moving up and down and shit like that, I guess. There's clauses and instructions moving towards or below. That you can. Oh, maybe they mean like a wave. Okay. Director end begin. Oh, so here they're just kind of implementing this kind of stuff, boilerplate stuff, I guess, for utility. Bit filled in. I feel like they could probably just use a library for this. Boost might even have it, but for something this low, I guess they always do whatever the hell they want. And this is kind of one of the other things I want to solve, right? So you don't need the language and libraries are very composable and very kind of like fundamental, so that portability and stuff like that aren't really issues anymore. There's even like FreeBSD is written in C. C is supposed to be a portable language, but I mean, it's gone to a point where you probably couldn't even compile FreeBSD unless you already have like a FreeBSD system that you're kind of compiling on. So that's kind of just what happens, I think. Mesa compiler. So say allocation spilling. Cost lower register usage. Oh, so kind of like spilling from overused registers to either memory or vector registers, I guess. I guess in this case, it's probably just kind of scratch memory. Yeah, scratch memory. Divergent analysis pass. Oh, so that's good. They're kind of doing a lot of that. And yeah, I guess a better compiler would probably help quite a bit. better drivers, I heard too. I'm not sure if the driver, kind of like, quote unquote driver, actually kind of just refers more to this kind of thing, the compiler here. Yeah, because I've heard that, and NVIDIA, and I think Intel especially, they fixed some of their compilers and their drivers, kind of updated a bit, and they got significant FPS boosts. So that maybe they already kind of had those updates in mind already, just not pushed into the release, and they kind of just released it after they kind of polished it up a bit. Because I guess you have to go from stable state to stable state, and maybe at first you want to play really, really, really safe, so you don't, result in blue screens and crap like that, or freezes and stuff, or crashes. So maybe you just release the really shitty driver at first that like is stable and works. Then later on you can always release the better one. Lord, hardware instructions. Oh, okay. So I guess that's mostly 1-to-1 with the instruction selection phase, I guess. Just a different format. Optimization, moves, constants inlined, reduction template. Oh, pseudo instructions as well. Utilize linear reach. Oh, okay. So that you can actually optimize by doing that. Exact mask. Lanes are active. Divergent branches. Oh yeah, I think that's the stack, wasn't it? Or maybe not so much the stack, but controlling which kind of threads, and then you could if one thread kind of returns early, you could probably turn that off on the next cycle or something like that. Niggas, fucking nigga. Yeah, I think we're kind of converging to a point where you kind of do have to have this kind of complexity. Oh, wow. So I think, is this like this scheduler works on the CPU or what? Or is this like a static scheduler? Aims to move up memory load as far as possible without exceeding the maximum memory register. I'm guessing this is some kind of CPU scheduler that schedules the threads, tells the GPU threads what to run, or the batches memory loads as far as. Few more moves than to sacrifice a wave. The register allocation does SSA reconstruction. Vector of neighboring registers to be available. Shuffle code. Oh, I think in the hardware it actually does that, right? So it kind of does register shuffling or register allocation on the fly as well, because the register numbering isn't actually 1-to-1. There's actually generally more registers available inside the hardware itself. Probably the bigger the GPU, the more the registers are kind of there as well. Again, hazards and no hops. Hazards, I'm not really sure what they mean by hazards. Oh, yeah. So you would probably cause a stall because it's going to take more than cycles, I guess. Wait, states are to resolve hazards. hazards. Okay. And what kind of instructions might lead to that? Instruction hazard. Oh, so if you can remove them, then maybe try to remove them. And that instruction's waiting. Because I don't think you can resolve them completely. Only the ones that can be resolved. Some differences between each hardware generation. Yeah. Okay. And I think they kind of covered it here, right? Each instruction format, they're trying to encode the instruction for that. What about the I mean, where's the lowering? Is it the final lowering? Instruction selection. Their generation lower to maybe this. Yeah, so this is probably it, I think. GFX 10. Oh, man, 64. T1 VOP. Do swap. Actually, I'm not even sure about this. Jeez. And I mean, it's again, with probably a better setup and dependent types and stuff like that, you probably don't need to have these kind of things in the code itself. But it's probably, I guess it works, which is the most important part. But it's going to be pretty much I don't know how they're going to, if they want to upgrade something like this. I mean, good luck, I guess. Because I know there's a lot of code bases that kind of look like that, right? If you look at something like Haskell, it's generally much better, I would say. Rust, I think, is starting to get kind of bad, but they do have better kind of just stuff in general to facilitate just better object-oriented programming and functional programming in general. So this is kind of pretty high R kind of stuff. I guess, I mean, would this be the most interesting thing in terms of, because I'm not even sure if the I/O control is really that interesting. You're basically just sending the command buffers, I guess, or doing config things to tell the GPU to go into different configurations or output different resolutions or frames, or maybe allocate memory. GPUs are literally so they just seem so overcomplicated nowadays. Could probably look at something similar as simple as well, to kind of get a better idea. But I think that pretty much tells us, look, this is kind of like the back end version, how it kind of wants to compile SPIR-V or some stuff to the stuff. The DRM shim registers Vulkan. So this is also pretty good too. So this is kind of some of the config stuff, eh? Yeah, Codex H.265. Oh, they support that now. And again, all this setting of stuff. One of the things that I kind of want is to not have this setting, maybe, if possible. I'm not really sure though. It might be better to just kind of read everything from a config file, or just a vector. And you kind of just do it that way. And kind of try to force that style from the beginning, so that you never have to end up where you just have 10 statements in a row, where we're just setting things to some arbitrary number, and um, passing that around. And again, you see things like H.264 like a billion times already as well, right? You have to find destruct. Um, yeah, wait, you're casting it to that, okay? Okay, and that's kind of one of the things like, uh, I don't know. They're not even using like static cost or anything. They're using um, it's their thing. They're not using like an int or a trait that would facilitate that in a more explicit way. They're kind of just reinterpreting it, I think. Reinterpreting a void pointer. Um, which, I mean, I guess if you know it works, it works. It's not that big of a deal. And again, like set stuff, check, set again, copy memory, and it's yeah, generally quite typical code, I would say. Uh, mm, um, gonna want to read the book later, but damn. Oh Jesus! And you'd think there's probably gonna be a better way to do something like this, right? But I guess if it works, it works. SPS info, PCM enabled. Yeah, because then, I mean, if you also have like a config file, then you have to maintain that as well. It might just be, maybe it's lazier and simpler in the long run to just have something like this, where you want to change something, you change something directly and you can see it. Something like this, you can see exactly what's happening straight away, I guess, pretty much. Compared to reading config file or something else like that. And I do appreciate the fact that they're not using as many like compiler directives, because in some code bases, I like half of the stuff are just if def, if not def, blocks, and it can be kind of it's just like it's not even like Rust, where Rust you can have something similar, but I feel like it's just much better because of the way the language server, the Rust Analyzer one by that made by that guy, really cool guy. It's a it kind of grays out the stuff properly and actually kind of shows you, but the way that C projects are set up, you kind of have to set it up even further and stuff like that. I'm just not really bothered to do that, and seeing a whole bunch of those if def blocks is just like, oh, um, yeah, especially since those if those feature blocks, they're not even like features, right? In Rust they control it so that they have to be either features or whatever, specific. But there it's literally just any define, like, and you can kind of just do that. Check that, copy on that, compare on that, compare copy. Oh, man, what is going on? Copy mask and flag. This field's not supposed to fill in test. Oh, so change the field to the source field, and then do a bitwise OR of the flag. Stencil. Oh, okay. So this stencil depth. Seeing cull. We're seeing depth bias, rasterizer. So these things that the AMD GPUs know nowadays. Damn, that would be pretty cool. Yeah, look at Bifrost. I think, I don't think I've seen that much stuff on that, but again, it's, I'm not even sure if it makes sense to accelerate some of these things as well. Maybe it is. Ah, damn. No, probably look at this at some other time. But hopefully that kind of shows, like, just I mean, how fucking, yeah, how fucked it is, man. DRM. So yeah, if you're using Linux and shit, it's probably what we're gonna try to do. IO control. Info. Oh, it's basically info for IO control. What about the actual IO control non-info stuff? Can I look at the render or anything? Shader DB. Shader database. Shader DB again? Oh, so there are. It's just for them to kind of check things out, I think. Common. AC binary. Oh, sorry. Fork. Not vendor. Tile. Like tile rendering or what? Bit shift mod. I mean, I don't even see what the hell. I mean, there's a billion different things. Wow. Shader utilities. Work group allocation, compute allocation. Oh, man. Empty family. I said config files, I guess. NIR. NIR. That's the IR, I guess, they're using. It's the memory. Oh, man, this is so, like... Might have to go to Linux again to kind of look a bit at the specific DRM functions that they're using. RAD-V driver. Or maybe not. Maybe in the Vulkan driver, it's probably probably tells us enough if we look at it a bit more. Because the IO control is probably just as simple as just sending something. It's probably not that important. DRM and gem, I guess. Whew. Android as well. AMD on Android. Gallic. Pipeline. Graphics. Oh, wow. So they actually have a way to... they actually have a driver for this. Okay. Blend enabled. So they're kind of like riding the mask and turning as well. Okay, that's just the checking function though. Needed dynamic state. Jeez. So I think this is probably the file we want to look at. Pipeline graphics. Because that's probably a lot of what the code is. Like thousands of lines of just code doing stuff. Has NGG. Okay. I think that's good enough for today.